Okay, gang, you've arrived at the soils, the last part of this course, the soils part. This is actually a site I've been coming to since I moved to Missoula 10 years ago. You can actually see the soil pits we're working at today on Google Earth. That's how long they've been here. So in lecture, we started off talking about, for my part of the course, we started talking about the 5 factors that influence soil development, right? You guys all remember what those were? What are they? Climate. Okay, so let's talk about climate for a second. What's the climate like here? It's pretty arid. Do you know how much average annual rainfall we get in Missoula? And the med station in Missoula is at the airport. It's around 13. So just about every month we get about 1 inch of rainfall, except for May and June, where we get about 1.5 inches. Okay, so we're entering the wet season in Missoula. Okay, so the climate in this general area is not going to change, right? If we move up to Snowball, obviously the climate changes. But in this area, we're talking about one site, right? And it gets one amount of rainfall, and it has basically an ambient temperature. Okay, so the climate clearly could influence soil development, but we know that that's not changing at this site. What else influences soil development besides climate? Already, chlorped. You guys remember chlorped? So what's chlorped?
Organic matter.
Organisms. So that's one. Climate, organisms. Oh, so what sorts of organisms do we have here? Mostly grasses, right? Bunch grasses, some non-native, some native, some sagebrush, right? You should notice some other things in the valley here in the lowland part here. What's that down there? You guys know what that is? Snowberry. Okay, so there's some variability, but mostly we're in a grassland site here. What else influences development?
Parent material.
Okay, I hear 2 of them. One, I hear parent material. So the parent material at this site is actually the glacial Lake Missoula parent materials that I was talking about. Okay, so in the last glaciation, the Purcell ice sheet, the Clark Fork River essentially was backed up by the Purcell ice sheet, which formed a dam, and it formed glacial Lake Missoula. So almost this whole valley, all the way up into the Mission Valley, down the Bitterroot, this was all underwater for some fairly lengthy amount of time. And at the bottom of that lake, every year, right, sediments would accumulate. And the soils we're going to look at today are actually remnants of those sediments. Okay, so those sediments were fine textured. You'll see they're pretty interesting pink colored. And I want you to look for evidence of the unweathered parent material. That's kind of one of the things we're going to be looking at very carefully for today, is evidence of the unweathered parent material. So the evidence of the unweathered parent material in a lake sediment in a lacustrine system like this is actually layers of sediment, and you'll be able to see those pretty clearly, and I'll walk around and show you what those look like. So look for those. Topography. Okay, I know for the last couple of labs you've been looking at the effects of topography, or kind of variation hill slope position, on hydrology. So how does topography influence soil development? What do you got? Okay, so we have a ridge basically here, and it's running off into our valleys over here, right? Does that have anything to do, you think, with the type of vegetation that we have on the ridge versus in the valleys? Yeah, because you need more water essentially to support snowberry than grasses. So something about the overall topography is influencing probably vegetation, and there's a really strong correlation, remember, between vegetation and soils. What other elements of topography are important here? Aspect, right? This is always striking on a cloudy day like today, because the people who are working on this side always are warm and toasty, and the people who are over on this side are often quite a bit cooler, right? So the sun is sort of tracking that way, right, from east to west, and mostly on the southern sky. And so this, even though it's subtle, this side of the hill slope is getting much more incident radiation, so it has higher temperatures. What else do you think that translates to in terms of soils? Drier soils, right? So southern exposures tend, and you can see that, right? If you look back and Mount Sentinel, right? The northern exposures on the hill slopes tend to have forest. The southern parts tend to have grasses. Here we have all grasses, but one of the other things I want you to pay really close attention to today is how does a change in aspect influence soil development, okay? And the other thing, the last thing we haven't talked about is time, okay? So how long has it been? And we know that this site started developing when Glacial Lake Missoula drained for the last time, okay? So we have a site that's got one climate, it's got one set of organisms, okay, until we move down to the valley or into the gullies here. It's got the same amount, it's been developing for the same amount of time, okay? It's got the same paramaterial, but what we're really going to look at today is the difference in topography and how that influences soil development. So whenever you want to investigate the effects of one thing like topography, you have to keep all the other things the same, okay? So we're keeping everything the same. We're going to look at soil development on the south and on the north sides. Okay, so let's think about some hypotheses about what we might expect. So we said on the southern aspects, it's probably warmer, right? More radiation and drier. Okay, so all other things being equal, which side of the slope here, the north or south, would you expect to have more well-developed soils? So more weathering. Why north? You're right, but why?
Because there's less direct sun.
Yeah.
Sunlight.
So how does less direct sun and sunlight translate to soil development?
It's probably more moisture.
And why, as it relates to sun?
There's less evaporation.
Less evaporation plus transpiration, right? Don't forget about the plant part. So the hypothesis would be there's more evapotranspiration on the south side, okay? That means less of water available for weathering, right? Remember this concept of effective precipitation? So lower effective precipitation on the south side, so you might predict less developed soils over on the south side than on the north side, okay? That's consistent, at least, with how the things we've talked about and the factors that influence both rates of weathering and thus soil development, okay? So how would you assess or interpret whether these soils are more developed or less developed than these soils? Depth, okay? And specifically depth to the unweathered parent materials, okay? So this is exactly what we're going to do today. We're going to look at soil depth on a north-facing slope over here, a south-facing slope over here, and then at the end of the class, we're going to go down by the snowberry and this gully down here, and we're going to look at the soils down there, okay? So given what we just hypothesized, right, that more radiation translates to warmer temperatures, more evapotranspiration, less moisture available for weathering and developing soils, let's look at how developed each of these soils are, okay? So how are we going to do that? Well, we're going to look at several soil pits on both the north and south facing slopes. In your groups, you guys have groups?
Usually count off.
Okay,
or
so
they
we'll
can split
count
up.
off again. I think that's good. You mix it up a little bit. Ultimately, we'll have groups working on both the north and the south slopes at the same time. We'll give you 20 minutes or so to collect the data you need. Everyone will switch. We'll finish that. We'll go look at the thing together, and then by about 4:15 or so, we'll start making our way back to the buses. Okay? So what are you going to do? You're going to, basically, what you need to do or the assignment for this week is to complete this table on here. Okay? So I have a couple of things I want to walk through. So depth to calcium carbonate. How are we going to test for calcium carbonate? How did we do that? Do you guys remember? Yeah, the acid. So we have the weak dilute hydrochloric acid, and we're going to look to the depth of calcium carbonate. Okay? So let's walk through this again. So we have drier slopes, less water, cooler slopes, more water. On which slope would you expect that calcium carbonate to be deeper? Why? You're right, but why? Okay, so you have the source of the weathering, but why would it be deeper in the soil profile over here? Well, and how is the weather material getting deep?
More moisture.
What's taking it there, right? More water. I'm always competing with the trains out here. So there's more water essentially to drive that calcium carbonate, which is just a soluble ionic chemical. More water to take that valley. What do you think of calcium carbonate? Sour or deep? So there's more water there, it's more drugs. Okay? One of the things we're going to look for is depth of calcium carbonate. So we're going to look at overall depth of the soils. We're going to look at depth to the barbs. The barbs are, in this case, unweathered characters. The actual evidence of the layers of sediment. The layers of the soil too in terms of differences. So you have a surface layer and a subsurface layer. I want you to actually look at those like you would a normal soil profile. So try and identify fertiles that are different in color. Identify where you think the color transition happens. Use the soil kit, for example, like pH. We're not going to do texture today just because we don't have as much time today. You get to your soil profile, just lay it out like you see it, right? So you see it, you think it's a surface layer, you nail in where you think that ends, and the subsurface layer begins. And then I want you to look for how deep is that surface horizon? How deep is the surface horizon? How deep is it to the unweathered parent material? Okay? And then each of those layers have a potential layer in it. Try and identify where you see calcium. Okay? So we're going to take these measurements on the north and south, both groups, and we'll try and keep you on task here. And then at the end, we'll look at these together, and then we're going to actually walk through some of the questions and discuss some of our results as a group. That'll make writing this week's lab report pretty straightforward, right? So we're all on the same page before we even. Okay? Excuse me. Any questions about how this is going to work? No? So we'll have you do by sections or something?
Yeah, 6 weeks.
Each group, 6 groups. Each group will need a soil kit, a shovel, and when you get to your pits, clean off the profile, and you'll need a spray bottle. Okay? So let's get the count off completed.
Oh, we can even use this. Or I don't know. Go ahead. These holes are gonna be huge. By the time everyone. Okay. Nice. And now we spray?
Guy who knows how to use a shovel.
Are there specific instructions in the lab? Yeah, it says procedure. So it says
Procedure.
what the profile for this spray bottle. Okay.
Yeah, observe the different horizons.
Okay.
Okay, and then we have to mark it with a knife. Yeah. I mean, a nail.
Stay away from you when you're mad.
Right.
Should I wet it more? Maybe.
Yeah.
That's hard.
Like where the vegetation is. I think that's so I don't know. Don't even. I feel like kind of. I know, right?
Oh, but that could
Nope, you don't have to do the whole data chart today. So this is the date. This is what we're using.
I feel like this is tomorrow, right?
Yeah.
Yeah, so
it would make this.
The roots go down to
Look at my clothes.
So that's basically once you get into the layers, and you can clearly
Yeah, it's hard dirt. Yeah, good enough.
The barbs would be out from the surface down to the top of it.
Where does it start getting lighter?
How's it going?
We're having trouble.
We don't know yet.
And plus, how wet do you? Maybe
Okay.
more wet?
So did you put this? Oh, you sprayed
it.
this one?
Yeah.
So that looks good. So now if you look down here, right? Well, this is actually perfect. So
Oh,
there's,
so we shoveled
that's fine.
this abuse. Okay.
Yeah, I'm just showing you, this is basically the unweathered parent materials. So you see all those, there's clearly like
Yeah.
light and red, and then you can peel these apart actually really
Layers.
easily.
Yeah.
So each one of those basically is an annual layer that was laid down when the lake was here.
Wow. That's cool.
Okay, and so that's the parent material.
Okay.
And so now what's happening is the soils are being weathered, and so at the surface you can't really see these anymore, right? Because you've taken parent materials and essentially weathered it to the point where you can't identify the layers anymore, okay? But what we're really looking for here is how deep is it to that unweathered parent material, okay? So that would be the depth, thickness of A, kind of a surface horizon, if you can see two different horizons in there. Thickness
Yeah.
would be how depth to the varbs, and then where is the calcium carbonate. So you can sort of walk through, take a little
Sorry, so would you expect those?
shovel and do the calcium carbonate test.
Would
Sorry,
you
go
expect
ahead.
those layered parent materials? I guess that'd be the non-parent, the layered, where you can see what you just showed us. That would be non-parent material.
It's parent material,
It
it's
is
just
parent
unweathered parent material. So it's not soil, right? So
Right.
basically the difference between soil and parent material is one has been weathered and one hasn't.
Right.
So in this case, we identify the layers that haven't been weathered as the layers where we can still clearly identify, or as the...
Is it easier to see not like more stuff here than this that we just scraped
Could be.
away?
I mean,
Because I feel like it just looks all
it looks all the same.
Towards the
so where do
bottom,
you
you can
identify
start
the
to see
varbs?
lines.
Right, you pointed out
like
before where it starts to
Oh,
get striped.
top,
yeah.
or like that bottom third
Oh,
down
yeah, I
there.
see it.
Exactly.
there.
So that's what I started grabbing. So if you come and you're
That's the unweathered parent material.
That's right.
I
You can
see,
see if
okay.
you look at the drier stuff here, that's where it becomes really clear. But there's clearly layers, and it actually comes all the way up here. I would say.
Yeah,
See
that's
them in
why
there?
I think it's
Yeah.
easier to see.
Yeah, it could be, and sometimes it's easier to do it right in the direct sun.
Yeah.
So wherever it's easiest, you can look wherever you want.
Okay. Yeah. And we just measure then how.
Yeah, so what I would do is, like, if you're coming to a soil pit for the, to try and learn something about the soil in an area, the first thing I would do is like wet it up like that, and then so you put a nail in here. So what's going on? What would you say
That's
is?
like our
It's
layer.
like our vegetation layer.
And so why did you put the nail there? What is the distinguishing characteristic of this that makes it different than this? Okay, so it's a little bit darker. Okay, and that's what you would expect, right? See all the roots in here at the surface of these grasses, and that's where most of the organic material is going to be added. Okay, so you only had one nail.
Oh, we've got
here.
more.
Oh, thank you. Okay. So that's a layer, right? And we know that we said that there's a layer here where we go from soil into parent material, right? Where do you think that is?
Right.
Okay, I agree. So, and that's sort of consistent here, right? So this is pretty uniform dirt here, but then we get into these layers right about here, right? So what I would say is now you could go through and do your tests, right? So if we were going to fill out the entire data sheet, you could do texture and color and all that stuff.
Oh, we're not doing that today.
We're not going to do all that today, just in the interest of time. But what I would like you to do, like I do think it would be, to actually identify if this is a different layer than this, you could check and see if you can identify a difference in color. But ultimately what I really want you to do is depth of A, depth of B, and then look for that calcium carbonate and where do you see it. So you could take samples like every few centimeters here, put some of the hydrochloric acid on it and see if you get a reaction.
Okay.
Okay, so let's do that together for the first part here. So we'll take a little here. Yeah.
Just sprinkle.
Just drink it, sprinkle a little bit, not drink, don't drink it. Okay, you see anything?
So, yeah.
Okay, so there's a reaction. So we get a reaction at 2 centimeters. Okay? Let's see if we see it down low. Yeah, see that?
Yeah.
So you basically have calcium carbonate reaction through the entire profile.
And then do you want us to get an exact measurement of that, or just say the whole profile?
So I want you, so just exactly what's on here. So depth to calcium carbonate. So if it's right at the surface, I would say that's 0, right? It's right at the surface. And in fact, let's see. I wonder if we can just drop it on the surface of the soil and get a reaction. Nope, so it's not right at the surface, but it was right at 2 centimeters.
Now, could that be because the rain has pushed it down into the next layer?
That's right. That's exactly how it gets. So the calcium carbonate is just a soluble compound, and when it gets moved down with water, but when it gets to a depth where there's no more water, it precipitates, and that's what we're seeing the reaction. Okay, so it's not right at the surface, but it's right just below the surface there. Okay, so at the depth to calcium carbonate here is whatever depth we took it from there, so 2 centimeters. Okay, this would be A, this would be B. Right, that's basically
Vegetation would just be grass on top.
Yeah. How's it going?
Good. Just making sure I'm not.
Make sense?
Yeah, and then depth of the wire.
I'm gonna let you guys do the measurements
Yeah,
now.
thanks.
They're really on there?
There's a tape.
Okay. So what's going on in that top layer you think that's different than the next layer?
I think that's
Okay, I agree. So then you have a change here. What's going on? What's the difference? I agree with this. So what's going on between that green nail and that one that makes this combination?
So from here, so from here to here is that correct?
No, that's B.
Yeah,
That's
from
right.
A is from A.
Well, and then it's like A.
Okay.
I thought the
or
depth
not.
to vars was all the way down to the parent material.
Okay, so A is just right here.
And then thickness of A is that. And then thickness of B will be between the two nails.
That's like
So what I guess what I'm asking is, we're asking you to look at it. Is it really a difference in the soil or is it a change in the parent? Yeah, so you can imagine there's going to be things when the lake was here that might have caused variation, like in the thickness of the layer.
No, it's the thickness of the second layer.
The
So,
parent material stops.
It's like 5.
so between the two nails.
Pardon?
This is south slope.
5 inches? 5 inches. And the depth of the parent material is from the top. And I think that'd be to the second nail.
He's a killer.
Because that's the depth of the unweathered material. Yeah, so isn't so it would start from the top. This is the unweathered material.
So it should be 7 inches.
Yeah, totally.
Oh, depth to the parent. Okay, yeah. I see, sorry. Thought it was like of it. And I was like, isn't that about okay? So the depth should be like 7. Yep.
What is this one?
7. Easy.
Depth to var.
Bars. Yes. So it's like the depth from the top to the parent.
Because bars are the unweathered parent materials, the layers of sediment.
Oh, and that's where that one started.
And that's just type of vegetation?
I just said there's grass on
Okay.
top. Cool. Okay, that's it? I was like, we're not doing anything.
Okay, done. Pack up and move to the north side.
Yeah, onward.
Otherwise, I have a DOG. Yeah, we gotta kind of limit
I feel like the dark layer goes deeper on this one than what we did on the last one. Yeah.
Otherwise, you get confused and think that that's
I mean, it's significantly darker in the first place you pointed, but it's still much darker in the second place.
Yeah.
Probably going to be darker, deeper.
Darker, deeper. That would make sense.
Yeah. So where are the nails?
Yeah, I feel like right around where there's those.
Certain layers, yeah.
So, like, It looks like it's in here.
Yeah.
There's a huge, you guys, next time you drive west on I-90, at 9 Mile, you go through a big road cut, and you can just see, like, it's like 10 meters thick of these varves.
Wow.
These unweathered varves.
You can see the gorge?
The highway goes right through the road cut, goes right through these old layers. And some of the varves are this thick out there.
Wow.
So it was a place where there's lots of accumulation.
Are you talking about like exit 25 before the
Alberton?
5,000 silver dollar?
It's way before that.
Oh,
So
okay.
it's actually, you go, it really is right past 9 Mile, right before the highway goes back down and crosses the Clark Fork.
Oh, okay.
Right,
It's
at the bridge, right before the bridge.
Correct. You know what I'm talking about?
Yeah, I know
You've seen
exactly
it. Now
what
you
you're
know
talking
what
about.
it is. That's
Yeah.
the same as this.
Okay.
So they were accumulating much deeper layers out there.
Okay.
There's also a bunch of them. If you go east towards Drummond, there's another spot near Drummond, which is basically the eastern extent of Glacial Lake Missoula. And the road goes right through them there too.
That's crazy.
It's pretty cool.
That's way cool. I wasn't sure how much of that was from the construction of the highway.
The layers, or
Yeah, I didn't.
No, it
that's
was
what I've
all
always
from
associated
thousands
it
of
to. I
years
didn't
ago.
think about it. That's
at the bottom
awesome.
of the lake. I know.
That should be like plaqued or something.
It's really cool.
People should know
And
about
so that's why all this is really fertile agricultural land out here, because these old sediments just have they're holding lots of nutrients and good for growing crops.
So you'd expect
Okay, yeah, because you never weren't there.
You'd have to see a profile, right? Especially like your first, like.
So right here.
I think it depends on where you are. So over there, they are very near the surface. Are you seeing any varves over here?
Because the varve is just the unweathered.
We're not sure.
It's the layer.
It's layered, but I don't know that that's the same thing.
Because I don't see
Grab one of
any
those
stripes
clumps
in
and see if
there.
it breaks
Look
apart
for
like
the
that
really
otherwise.
clear stripes, though. And do it. Make sure you I would clean off one of these faces with your shovel again and start from scratch.
Yeah, well,
Do you want to clean?
Get the shovel.
Here you
Aw, he took my shoveling opportunity.
Oh, you want it? That one's a little bit weird because it's
got that
it's got the
crimping on the
grooves,
edge,
and I
yeah.
think it
Yeah.
messes with you a little bit.
Well, that's
Is that for like the grooves for like grading or something? Or just,
I don't know.
to help
oh,
I think it cuts better.
yeah.
You don't
See,
have
I
to
don't
sharpen it
see-
ever.
Do you see anything that looks like those layers in there?
Do we need to dig deeper?
No, you don't have. If you can't find them, you don't have to. You might be digging a while to find them over here.
Oh, okay.
So with that, you can.
So see a deeper.
So remember, the hypothesis was on that side there's less water, so less weathering, and on this side there's more water, more weathering. Well, there's not. There's
deeper
just.
organic.
They're just.
Sorry.
If we had a backhoe and kept digging,
Yeah.
we'd eventually hit them.
Totally.
But they're just deeper because there's more.
Where would you take it on here? Because I see it in a couple different spots. See over to the right of it, it's a little higher, and then over there it seems a little lower, and you can't. I don't know. I guess I don't know if the color.
Are we going with the lowest depth, or are we going with the most consistent, or?
The low. What do you mean?
So like there's a color variation
Okay.
that seems to be indicative of organic matter, and it
Agreed.
varies across the whole. So do you want to have like an average depth, or do you want to go
Oh,
with
you
the
mean
lowest?
it does this?
Yeah.
Yeah, that's fairly typical. I would just do it where you happen to be marking it.
Okay.
But that's sort of the wavy boundary as opposed to like a very
A flat
consistent boundary.
Okay.
That's pretty common. In the end, describing soils and soil morphology in this is more of an art than a science.
Okay.
If you were actually describing a pit, if you were working for the USDA and they were like paying you to go out,
Yeah.
they might have a protocol, and I'd say like looking at sort of an average might be a good one. But for this
Okay.
purposes, like let's just do the best we can with.
Okay.
Nope, it didn't tear either.
I would think it would be deeper
Probably
on this side,
deeper,
right?
yeah.
So it's
Probably a
right
lot
on the surface.
because there's
Yeah.
more moisture to
Yeah.
push it down.
Significantly more.
How's it going?
Try like every 5 inches or so. There you go.
All right. So go somewhere between those two marks.
Yeah.
Yeah.
So what do you think we'd find down there?
That's pretty good.
Okay, let's make some guesses. So deeper horizons. What else do we know
so
about
lower than
that?
that.
That's different, that might affect the soil. Okay, so organic materials, so we have stuff that's moving. We have water that's basically settling. Water makes things more productive, so maybe more organic matter down there. I like that.
Oh yeah, that was a pretty good guess.
Guesses about how things may vary down there. Overall, I was
A little bit, yeah.
Okay.
So let's say that's where it starts. It would make sense there wouldn't be a whole lot there.
This is where.
Calcium
yeah,
carbonate.
there could be if you have more weathering, right? Over the same amount of time.
We don't have a
But over that
B
same
or
amount
depth of bars.
So it'd be 11.5 inches
Not only does it
to the calcium carbonate.
yeah, it's more productive.
And then just the thickness of A, I
The
guess.
effects of
The
topography on
surface
soil
one.
development are largely
Yeah.
Is that B?
Well, that wouldn't be B. That would be
That's
depth
depth
to
to
calcium carbonate.
Yeah.
And then for B, we measured how much between the surface and the parent material. But we don't have parent material, so we can't measure B.
Yeah. So the thickness of A is 7 inches.
Wasn't that depth to bars? Though the one from the
Depth
We
of
don't
bars
have
is from
bars on
surface
this
to
Yeah.
parent material, and then thickness of B is from A to parent, or A to
Oh,
B.
to that. Okay. Yeah.
B was the
Okay.
line for the parent material, but we can't get the parent material, so we don't have answers for either of those.
I put undefinable.
But there's grass here.
Yeah, just NA. So we have no thickness of A and no depth to bars because there's no parent material.
That we can
Thickness of
find.
A is 7 inches. No thickness of B.
Thickness of A is 7 inches. Thickness of B is 7 inches.
Alligators.
Does that look anything remotely similar to what we just saw?
No,
What's the difference? Obvious difference.
it's all dark.
It's really dark, right? So why is this so different?
More vegetation.
So there's more vegetation. Well, qualitatively, I'd say a little bit, but there's definitely more. We know it's more productive because we have bushes, right? Whenever you go from grasses to bushes and bushes to trees, you know that there's more water, right? Trees need way more water than grasses. Okay, so higher productivity, just a hypothesis or a guess that this is probably a more productive site. So this is more productive, and let's walk through a little bit what we saw up here. Let me get my lab out. Okay. So, everyone know what a varve is? What's a varve? Weathered or unweathered? Unweathered, right? So we know that we've gotten into, we're not in soil anymore, but we're in unweathered materials. Okay, so let's talk about the south side. What was the depth to the calcium carbonate? Was it, there's going to be a bunch of different answers. Was the depth to calcium carbonate greater or less than the depth on the south side as it was on the north side? So was it shallower on the north or south side?
South.
Okay, so we had calcium carbonate closer to the surface on the south side. How come?
Because there's less water to bring it deeper.
There's the same amount of water to bring it deeper, right? So remember the precipitation right here is exactly the same as it is over there. Well, what's happening, what's the fate of that precipitation on the north versus the south side?
Evaporation.
More evaporation on the south side, right? That's why you always want your wintertime windows facing south, right, for the warmth. Or if you go into the desert southwest, all the Anasazi caves and caverns are all facing south, right? They weren't stupid. They knew exactly where they could stay warm, right? So more solar radiation. So we have more solar radiation. That translates to more evapotranspiration, right? Which is competing for water in soils, for competing with weathering, basically. Okay, and so we have calcium. Where is this calcium carbonate coming from? Does anyone know? No clue, guesses? What is calcium carbonate? What are the sort of pieces of calcium carbonate?
some organic.
Calcium, an ion of calcium, and what's carbonate? Okay, what else do we call oxygen and carbon? CO2, right? So CO2, carbonate is just another form of CO2. So CO2 can dissolve in water, right? And depending on the pH of that water, CO2 dissolved in water is carbonates. So this is like what's in the ocean, right? Dissolved CO2 is carbonate, okay? In the ocean, it's coming from CO2 that's dissolving or basically being absorbed from the atmosphere. Where is the calcium carbonate coming from in soils? Where is the source of carbon dioxide in soils?
Dead plants.
And dead plants, and what other kinds of plants?
Marine life. Live plants.
How about living plants? That's what I was thinking. So living plants respire, right? They photosynthesize when the sun's out, but when their plant roots underground are respiring, just like we are. Okay? Organic matter, when it decomposes, heterotrophic bacteria, fungi are taking organic material and they're respiring it and turning it into CO2. That CO2 gets respired into soil, into the soil solution, and it turns into carbonates. Okay? Well then if that water evaporates, those carbonates precipitate, right? And that's what we're seeing here, is precipitated carbonates from generations, like years and years, decades, centuries, of plants just respiring and decomposition happening here. Okay? That stuff gets carried by water into a deeper profile. So on the south side, we don't have much water. It's not going very deep. How deep was it to the calcium carbonate on the north side? Just a couple of groups tell me what your depth to calcium carbonate was. What was it? 30, 11, 15. Okay, so it's at the surface on the south, and there's quite a bit of variability over here, right? But we've seen even there's some aspect changes along this whole okay? So there's less solar radiation, less evapotranspiration, so more water available, both to carry that calcium carbonate deeper into the soil and to help it weather, right? Okay, so what does the calcium carbonate depth accumulation tell you about the conditions under which the soil formed? You feel like you have a good sense of what the answer to that is? Under what conditions would you expect deeper versus shallower calcium carbonate? I'm not going to tell you, but the answer lies in what this conversation, what we're talking about in this conversation. Okay, so I want to think for a second about, there's a couple of things that I wanted to chat about. That's this idea of an acquired versus an inherited characteristic. Okay, so an acquired characteristic, as you might suspect, is something that isn't necessarily native to the system. It was acquired from something. It was acquired from something that didn't necessarily begin here. Okay, so let's look at this. This soil again down here. We said it's dark. Is that darkness something that was inherent to the parent materials at this site? Okay, this is coming from, we said, organic matter, right? So the dark color in the A horizon down here, we said is organic matter, and that's something that came from organisms, right? So that's something about this soil that you would expect, basically in every soil that has a large amount of productivity, you'd expect darkness in the A horizon that reflects that organic matter. Okay? What about the pink color of our deeper soils? Where's that pink color coming from?
That's the parent material.
Yeah, so that's the parent material, and that's really the difference here. So there are aspects of soil, and color is one of those that we said could either be an acquired or an inherited characteristic. So the dark color in the A horizon is an acquired characteristic. The pink color of the subsurface horizons is an inherited characteristic. Okay, because the parent materials we saw in those bars, it's kind of pink, alternating pink and light and whitish, and that's what's giving the color that pinkish color here. Okay, so describe some of the major differences. You should have the ability to describe some of the differences. We know that the overall depth is probably different. We know that the depth to calcium carbonate is different. I know some of you had thicker A horizons in one side than the other. Okay, so just think about that. And what I really want you to understand walking away, if you don't understand, nothing else resonates here, what I want you to get is that we're in a site where basically everything is the same, but all we've really done is walked a little, like 25, 30 meters away, and we see very, very observable differences in soils, right? So we have a south side, shallow soils, deeper on the north, and now we're in this gully, and it's pretty uniformly dark. Wouldn't you guys agree?
Yeah.
There's nothing other than just dark, organic, rich soils. Do you think there's going to be a reaction there?
Probably not.
Who thinks yes? Okay, that's good. I'm glad to hear that no one thinks yes. That means that you at some level are getting this, which is always good for us. And any reaction? No reaction. Okay? Make sense? Questions?
So is that just all A horizon?
So I would argue that unless we can identify a difference between the top and the bottom, I would argue that that is just an A horizon, a big, thick A horizon. And if we kept digging, we would eventually find paramaterials, but they're probably really, really deep, right? Just because there's way more water and moisture available. Clear as mud. So, for putting this lab together, right, with these data right here, and this table, and our conversation, hopefully you have everything to get 100%, right? My goal in moving through the last two labs is for everyone to have exactly the information you need to get perfect scores on this, okay? If you don't, if something comes up in between now and then, Christine can help, I can help, I'm totally available. But does everyone have a pretty good sense of what's going on out here with the soils? Okay, and this is really, what this is really about is topography is affecting climate. Okay, topography by itself doesn't really affect anything. What it does is affect climate, the microclimate. Right, and if we were in the southern hemisphere, you might expect exactly the opposite. Right? If we went across Mount Jumbo, right, at the top of Mount Jumbo or Mount Sentinel, we might expect something different. Right, as you go from north to south, you might expect wholesale shifts in soil type. And I would argue that this is probably a mollisol right here, right? A mollic epipedon is this really, really dark A horizon. Those aren't mollisols right there, and they're 25 feet away. Okay, so soils change over really small scales, reflecting some really small scale variation like this. So I have, on my phone I told you about, I have only 3G, so this might not work. But I have an app, a soil app. So I'm going to open it and see if it can tell where we are, and it's going to tell me. Cellular data is turned off. So give me one sec. Well, I know what it's going to tell me. It's going to tell me that this is an alpha sol. So what's an alpha sol? Does anyone remember what an alpha sol is? You get 2 weeks to figure that one out. What's that?
First time we went over.
So alpha sols typically, I told you, are forest soils, but they have an argillic horizon, okay, which is an accumulation of clay. And what we didn't do is not only is the variation in the depth of calcium carbonate here, but there's a variation in the depth of clays. Okay, so just like the calcium carbonate, the clays are also moving via water into deeper soils. And this is an alpha sol developed from these glacial Lake Missoula soils. Okay, and it wouldn't, if if I was standing here using my app, it wouldn't know the difference between between the north and the south. So just recognize, even though you might be looking at a soil map of something and it's telling you one thing, but those are really small scales. Okay? Shall we go? Anyone have any last minute questions? Right on. So, well, go ahead.
Can you just kind of repeat a little bit about inherited and acquired? Inherited is just that.
So let's talk, that's a great question. So let's think, what are some other, so I said one is basically something that's coming sort of from the outside versus one that's sort of forming because of what the parent material provides or something like that. So let's think of another soil characteristic that would be inherited versus acquired. Okay, so is the calcium carbonate an inherited or an acquired characteristic?
Acquired.
It's acquired, right? You might have limestone, soils developing in limestone, and then that reaction, the calcium carbonate in that, could be an inherited characteristic. These parent materials by themselves are not enriched in calcium carbonate. But you could have a limestone soil that has lots of calcium carbonate, and that calcium carbonate is coming from the fact that it's limestone that's weathered. Okay, what's a good inherited characteristic? Let's think about soil texture. Is soil texture an inherited or an acquired characteristic? If we did the texture from this exact site on the first week of lab, remember, we got a silty clay. So is the silty clay texture an inherited or an acquired characteristic?
Well, if it moves down, can it be acquired?
Okay, so if we are saying, yeah, the enrichment of clay in the B horizon, that could be an acquired characteristic, but ultimately, like, the texture of this soil is set by the parent material.
Yeah.
Okay. So the varves here, inherited or acquired?
Inherited.
The varves. Inherited, right? That's something about the parent material. Yeah, it's the parent material was laid down in layers, and so the layering in soils that we see is an inherited characteristic. Okay, those layers were not formed after the site was right. The parent materials were here; they had the layers, and if you see layering in the soil, it's because of those parent materials. The texture, because we haven't looked at soil structure in much detail. But soil structure, platy structure. So layers, and so the platy soil structure here is an inherited characteristic because the layers, the sediments are in layers that comprise the parent material. There, does that make it a little clearer? So it's a little tricky, right? Because there's fine lines, right? Color can be an acquired or an inherited characteristic.
So would you define the parent material as whatever was left by the last draining? You said the last draining on places.
So the parent material is whatever the most recent disturbance was, right? The most recent transported material, right? In the case of out here, this is all transported parent. This was transported by a lake, down by the Clark Ford, it's transported by a river, right? So let's say we had a volcano, a giant eruption, and it deposited tomorrow. It deposits a foot of ash out here, right? Then we have a new parent material, and we're going to start developing soils in that new parent material, right? Which is going to be different than this parent material. And so the trajectory of soil development is likely to be very different too. Right? The next day, if we had a big landslide and they all got buried, then we'd have a new transported parent material, colluvium. Okay? So soil development and the trajectory of soil development happens until you get something that sort of resets the clock again. Like a big glaciation or a lake fills and you get a bunch of deposits on the bottom, or a river floods or something like that. And it all sort of starts back up again. More questions? Did you learn something you didn't know? Hopefully. Probably never thought about soils very much, but this is really why it's hard to get a sense of this in a classroom, right? It's much easier to come out and look at soils. But hopefully that helps you. Next week what we'll do is we're going to go and look at a forest soil, and we'll actually walk through all of our measurements out there. And so in your mind's eye, just keep track of what this looks like, and then we'll see how very different it is once we step into a wetter site with forest vegetation. It's totally different. All right? So if I could get your help again, we're going to walk